figure shows a 4-bar link ABCD under the action of 4 forces F1, F2, F3, F4 acting at A, B, C, D respectively. The links are in static equilibrium. So this is very important. There are 4 forces acting on a system and the systems are in static equilibrium. So what is the meaning of that term, static equilibrium? So there are 4 forces. So force 1, force 2, force 3 and force 4. So finally it form a force polygon. 4 forces should form a polygon, closed polygon. So this is the condition to be satisfied for a static equilibrium. If it is 5 forces, again it should form a polygon with 5 sides, but it should be a closed loop. Closed loop means the last side connected to the first side. It should be a closed loop. Here our aim is to find the magnitude of F3 completely and the magnitude of F2. Here in this problem, F1 magnitude given. So this is also given data, 200 Newton. The angle of inclination 30 degree. So this is 30 degree. I can write 30 degree here. So for force 1, both magnitude as well as direction given. For force 2, only angle of inclination given, 30 degree. We need to find out magnitude. For force 3, both magnitude as well as direction unknown. So we need to find magnitude as well as direction for F3. Actually you should not represent F2 because we don't know the direction. So without direction I can't draw this line, but for understanding purpose only I am adding this line. So you need to find both magnitude as well as direction for F3. Then finally F4. For F4, magnitude as well as direction known. So there is no need to worry about F4. Here angle 30 degree. Magnitude we need to magnitude 300 Newton. If you take a static force analysis of any 4-bar mechanism, we always expect to find out F3, because in any 4-bar mechanism this is an input link, this is an output link, and here it is a fixed link. If it is fixed, then there is no need to worry about F1 and F4. So we have to worry only about F2 and F3. So F2 means input. Most of the time input will be known, at least angle. That's why F2 angle is given. Only thing is you have to find out magnitude. Again for F3, it's an output link. So the entire performance of F3 depends on the configuration of 4-bar mechanism. That's why almost all static force analysis of 4-bar mechanism we can expect as to find F3, both magnitude as well as direction. The actual purpose of this static force analysis is to find out the magnitude as well as direction, I mean the angle of inclination of force F3. Okay, so let me erase all these parameters. Now I'm going to do static force analysis. So step number 1, extend the line of action of F1. So this is called line of action. Just extend the line F1. Similarly, extend the line of action of F4. So both will cut at a point. Mark this point as 1. Now I'm going to move step 2. Now I'm going to move F1 from configuration diagram to force polygon. So this is how you can move. You can use roller scale, or you can use ordinary scale also, but only thing is you have to keep the at angle similar to this one. Here why I am moving F1, because both magnitude as well as direction known. So now we copy the direction. What about magnitude? Take 200 Newton as 2 centimeter. Mark this as 2 centimeter. Take 200 Newton as 2 centimeter. Next, I'm going to move F4 because the magnitude of F4 known. F4 equal to 300 Newton. Next, F4. Take 300 Newton as 3 centimeter. You can take any value. This is only for your representation. So take 300 Newton equal to 3 centimeter. Now connect this line. This is resultant. The resultant between two forces. Now I'm going to move this force from this point to this point. So you have to move like this. So this is an angle of inclination of resultant force. Now extend the line of action of resultant. Step 3. Again extend the line of extension of F2 because F2 angle of inclination known, so it will cut at a point. So this is point number 2. Now I can connect point number 2 and this point. Connect 2 and this point. So what is this point? This is A, B, C and D. Connect this point. Now you will get a line of action. So this is called line of action. Now you got line of action. Extend the line of action, then add an arrow mark. So now only you have to add this F3. See, you should not add F3 during the starting of the problem. So F3 angle of a line of action we have to find out. So how do you find that line of action of F3? Extend point 1, then extend the line of action of F2. Both will cut at a point, that is point 2. Then connect point 2 and C. So that represent the line of action of F3. So now we got the direction for F3. So this is a direction for F3. We can take it as theta 3. Now move this line F3 from configuration diagram to force polygon like this. Okay, now the only remaining line is F2. So move F2 to the end of, starting point of F1. So now, so this is an extension line because we don't know the magnitude of F3, and this is also an extension line. So both will cut at a point. Now we can find F3 and F4. Measure these points. So that is equal to F3. Measure these points. That is equal to F2. If you measure F2, you will get 3.8 centimeter. Let me erase this line. If you measure F3, you will get 2.84 centimeter or close to 2.8 centimeter. So we know that 200 Newton equal to 2 centimeter, which means 3.8 centimeter equal to 380 Newton. And then 2.84 centimeter equal to 284 Newton. So this is how you can find the magnitude of F2 and F3. Here we need to find the angle of F3. So how do you find the angle of F3? So this is F3. Move this line here. Just measure this angle. So this is F3. You will get close to 15 degree Celsius. 15 degree. So this is how you have to find the magnitude of F2 and magnitude of F3 and angle of inclination. Don't forget to post your questions in the comment box. You can also mention the topics which you expect from my channel. Subscribe my channel and like my video to support my video lecture.